How do compasses work? When Bob Dylan sang like a rolling stone, with no direction home, he obviously wasn't carrying his compass. Armed with a simple bit of magnetized metal, you can almost always find your direction home in an instant. People have been navigating with magnetic compasses for the best part of 900 years, so there must be something in it. What are compasses and how do they work? And what about the compasses people use in ships and airplanes where Earth's magnetism isn't always a reliable method of navigation? Let's take a closer look. What is a compass? The simplest compass is a magnetized metal needle mounted in such a way that it can spin freely. You can make one yourself by magnetizing an ordinary needle, placing it carefully on a slice of cork, and letting the cork float in a tray of water. Left to its own devices, the needle turns until one end points north and the other south. You can usually figure out which end is which from the position of the sun in the sky, remembering that the sun rises in the east and sets in the west. So if you're looking down on the floating needle at about noon, with the eye on the left and the point on the right, and the sun is somewhere in front of you, you know the point is indicating north. How do compasses work? Magnetism is one of the first bits of science we learn in school, and just about the first thing we discover is that like poles repel, unlike poles attract. In other words, if you hold two bar magnets so their north poles are almost touching, they'll push away from one another. If you turn one of the magnets around so one magnet's north pole is near the other magnet's south pole, the magnets will pull toward one another. That's all there is to a compass. The red pointer in a compass, or the magnetized needle on your homemade compass, is a magnet, and it's being attracted by Earth's own magnetism. Sometimes called the geomagnetic field, geo simply means Earth. As English scientist William Gilbert explained about 400 years ago, Earth behaves like a giant bar magnet with one pole up in the Arctic, near the North Pole, and another pole down in Antarctica, near the South Pole. Now if the needle in your compass is pointing north, that means it's being attracted, pulled toward, something near Earth's North Pole. Since unlike poles attract, the thing your compass is being attracted to must be a magnetic south pole. In other words, the thing we call Earth's magnetic north pole is actually the south pole of the magnet inside Earth. That's quite a confusing idea, but it'll make sense if you always remember that unlike poles attract, Earth's magnetic field is actually quite weak compared to the macho forces like gravity and friction that really dominate our lives. For a compass to be able to show up the relatively tiny effects of Earth's magnetism, we have to minimize the effects of these other forces. That's why compass needles are lightweight, so gravity has less effect on them, and mounted on frictionless bearings, so there's less frictional resistance for the magnetic force to overcome. And this is all about how do compasses work.